Hello guys, welcome to my channel Practical Engineering, Electrical and Networking. I hope you are doing just well. In today's video, we are diving into fascinating the world of wireless electricity. Isn't it sound very interesting? I'll explain how it works, show you some cool applications and even demonstrate a DIY project that you can also try at your home. You can also show these examples or show this in your practical examinations or your projects in colleges or schools. In today's world, we encounter the various wireless technologies without fully understanding how they work, right? Take a wireless charger for example. While this seems a wireless, they still require a device to be placed on the charger to get function, which limits their true wireless nature. Interestingly, the wireless energy transfer is not a new concept. Ancient principles of physics have demonstrated the similar ideas, though we often overlook them. For instance, consider the motor or induction motor. Everyone has a motor in houses. So, if we imagine it carefully or if we look at it carefully or if we examine its structure, you will notice that there is a small gap between stator and rotor. There they don't physically touch to each other, yet the electricity is get transferred between them wirelessly, right? Means we give supply to the stator only and the rotor start rotating, right? So which is wireless, we can say. We experiences a many such examples in our day-to-day lives, like motors, transformers, etc. This raises an important question: why aren't we advanced to using wireless electricity in home applications, right? Why hasn't this technology been fully developed for broader applications? This is a question. For small scale energy transfers, wireless technology is already feasible and safe, right? We already know that there are some wireless technology which is not dangerous to human lives. In the future, advancement may lead to home applications and devices being powered wirelessly. Imagine phones charging without a physical charger or even an electric vehicle being charged simply by parking at the designated station without need for plugging in. So this may be advancement, which is wireless energy transfer. This possibly represent an exciting evolution of short distance wireless energy transfer, right? As the technology advances, the dream of our fully wireless power solution may become a reality. However, we need to understand why it is not carefully feasible or practical to transfer the electricity over the long distance wirelessly. Means, up to this session, we have a small idea like at a short distance it is very safe and easily transfer the wireless energy. But we all know that when a single wire carries a current, it generates a magnetic field around it, as we know that. The best example of this phenomenon is electromagnet. For example, high voltage transmission lines such as those carrying the 400 kV produces a noticeable noise when you pass nearby. We have seen the various substations or in our societies or in anywhere we have seen the transmission lines where areas are often restricted to prevent the access because the electromagnetic field generated by these lines are very dangerous. In some cases, the strong electric field may pose a risk of attracting or affecting the human life, right? Making it unsafe to be near them. You guys might visit the industrial visit in a substation and the area is very restricted for high voltage transmission lines. Consider this simple example. When we supply a current to a wire or a coil, it generates a magnetic field around it. It can be practically possible at your home as well for a DIY projects. If you take some wire, you can wind it up to make it coil and generate a magnetic field around it. Now, if we place another coil nearby, this magnetic field induces the current in a second coil, right? Because of the first coil, the second coil is getting charged. When we connect a load such as a bulb to the second coil, the bulb lights up automatically. Why? Because of magnetic field generated by first coil. This happens because of magnetic field produced by the first coil transfers energy to the second coil through the electromagnetic induction. Here the concept comes is electromagnetic induction. We often came across this concept, but this is a practical example I have shown you. Similarly, the same principle is observed in mobile chargers. A coil is placed inside the charger and another coil is placed inside the mobile device. When you plug in a charger, it generates a magnetic field. This magnetic field induces the current in mobile's coil, allowing the device to charge wirelessly over the short distance. It is very short distance, right? However, to transfer the energy wirelessly over the long distance, we would need to create extreme large magnetic field. But obvious, because the short distance magnetic field can be produced very easily, but for long distance it is not impossible, but we need to create a large magnetic field, right? Such a field would be a highly dangerous, as it could harm or even kill a living beings that come into its vicinity even without a direct contact. You can imagine. This is one of the major challenge preventing the practical use of long distance wireless power transmission. This might be a challenge, right? Because this much of the large magnetic field is impossible to create. It is possible, but it harms all human beings, not only the human but also the animals, then birds and other insects as well. Now the concept of frequency resonance comes into the play. In technologies like Bluetooth and Wi-Fi, resonance exists in our surrounding, but it does not pose a risk to use due to its controlled resonance frequency. Okay, you can study the resonance frequency very deeply in other resources as well, right? Similarly, the Tesla coil operates on the principle of resonance frequency. Here you will get enough idea about the resonance frequency, but if you want to get a detailed knowledge, you may dig into it. You may already be familiar with the Tesla coil, right? Invented by Nikola Tesla, who envisioned the world powered by the wireless technology. That means, what do you understand from this? Already the scientists have worked on it to envisage the world powered by the wireless technologies. Remarkably, he demonstrated the wireless power transmission by lightning bulb in the 19th century using this technology. Okay, using this technology means resonance frequency. He has already lighting the bulb in 19th century. You might be wondering whether the wireless technology truly works or how it operates for the extent to the level we use today, right? You may already been familiar with a capacitors and inductors, right? As we are discussed earlier, we have already taken one example of the coil. So what is coil? The coil is nothing but, or essentially it is an inductor. Okay, when we combine an inductor and capacitor in the same circuit, okay, I am just drawing here one circuit where the capacitor and inductor is in same circuit. It creates a transient effect, right? These components work together to achieve the resonance frequency within the circuit, right? Enabling the efficient energy transfer or wireless functionality. Let me briefly explain the resonance frequency and how it works in a circuit. So here is a circuit, inductor and capacitor. It is alternatively charge or discharge each other. Okay, when a capacitor charges, it transfers the energy to the inductor, and when inductor discharge, it recharges the capacitor. This continuous energy exchange creates a specific wavelength which is called as a resonance frequency. Because of this, one wavelength is created, charging, discharging, and which is called as a resonance frequency. At a certain point, the circuit reaches a stable state where both inductor and capacitors are stage, both are getting charged and the wavelength is stable. This referred as a resonance condition. Okay. For this resonance frequency to travel through the air, it requires the high voltage. Okay, so this is at the small level, but if in order to create this resonance frequency at the large level, it requires a high voltage too. So Nikola Tesla utilizes his principle to create a Tesla tower. Okay, you may search in deep what is Tesla tower, how it works. A high voltage system capable of generating the powerful magnetic field. When the object like a bulb enters this magnetic field, it lights up due to induced energy. Okay, So the magnetic field also produces the spark. As we know that the magnetic field produces the spark, we have get some sparkable noise also. These sparks do not harm the human body due to the skin effect. We have already gone through what is skin effect, so we'll have some other session also for the skin effect, or if you want, or if you can dig down into the Google as well. So this demonstrated the potential of wireless energy transfer, right? Because of skin effect, it is not harmful to the human body. However, implementing this technology on a practical scale faces a significant challenges. It was only limited to the Tesla tower where it has created a large magnetic field and all. But there are some challenges. To transmit the energy wirelessly over a long distance, extremely high voltage are required, as I already told you, which are not visible. Additionally, much of the energy is lost during the transmission due to the obstacles and interfaces from other frequencies such as Wi-Fi and Bluetooth. If you want to create a large distance wireless technology, large voltage is first of all required, then other transient or other obstacles such as Bluetooth, Wi-Fi are already there. It will get affected because of this, or because of that the large distance or large wireless technology may get affected. This smaller frequency can disturb the large frequency needed for a wireless energy transfer, right? Resulting in major energy losses. So at the transmission end, if you have a large power, but at the receiver end we cannot guarantee the same power is been transferred because of the obstacles in between. Furthermore, high voltage transmission creates the intense sparking, making the atmosphere hazardous, much like a lightning in the sky. So it is very dangerous again. For this reason, while the concept of wireless energy transfer is theoretically possible, it is not practical viable on the large scale. So from this entire discussion, it is evident that the wireless energy transmission is feasible over the short distance. As we know that the short distance, it is very possible and it can be achievable also, such as within a home. This concept can be practically implemented for a limited range of applications. Through this video, we have explored the details of wireless transmission and its working principle. If you found this video very helpful, please like, share and subscribe to support me. Thank you.